Hello and welcome to the Bullion Tracker project. This is the second video in our four-part series. In the first video, we created a Python class to get the price of precious metals from goldapi.io, and in this video, we'll look at how to save that price to a database. And to do that, we'll use the Python library called SQLAlchemy. So let's start off with our command prompt window, and we'll navigate to the project folder. So I'm going to go to documents, and then Bullion Tracker env. I'm going to activate my virtual environment, then go into the project folder, and I want to do a git status just to make sure that we're on the correct branch. So we're currently on the develop branch, and I'm going to make sure that I have the latest version of it. And it tells us that we're already up to date. So I want to do a git log to see the latest commit, and the latest commit is the tracker library for gold prices. Now, if you recall, this is where we left off in the first video, where we created the Python library and then we committed it with this message. So we are now ready to continue from that point. So the first thing I'm going to do is I'm going to create a branch called database. And now I'm going to install the SQLAlchemy library. So let's pull up the documentation for SQLAlchemy. I'm going to Google SQLAlchemy, and I'll go to SQLAlchemy.org, and then I'll go to the library and reference version 1.3. This is the current stable version. And if I click on the installation guide and scroll down a bit, it tells me that I can install it using pip install SQLAlchemy. So let's do just that. And now that we have SQLAlchemy installed, I want to update our requirements.txt file. So I'm going to do pip freeze and redirect the output to requirements.txt. And we'll just do a quick git diff. And you can see that we added a new line to our requirements.txt file, and I'm going to commit that. All right, so now let's look at the documentation, and we'll figure out how to design our database table. So before we do that, let's think about what we need. So to design the table, or think about in terms of what kind of data we want to store, we want to store the price of the metal, and then which means that we want to store the metal. Then we want to store the price of the metal. We also want to store the date that we created the database record, or the date that we got that price. What else do we need? I think that's all we need for now. So we know that we need to store these three data points. So let's think about how we might do that. I'm going to go to the documentation. I'm going to go back, and we'll look at the this link here. Read this first object relational tutorial. And if you haven't already, I recommend that you read this this page. It's a little long, but you'll get a good idea of the basics of what we need in order to use SQLAlchemy. So I'm going to scroll down, and it tells us that for this tutorial, it's going to use an in-memory SQLite database. So we're going to copy this, but we'll end up, once we get the database working how we want, then we'll change this to use a file on our computer instead of in memory. So I'm going to copy this, and let's save this file, and I'm going to create a new file. Let's go back, copy this, paste it here, and we'll call this our database.py. So we copied over the import, and let's also copy this over. Okay, so if I scroll down a bit, it tells us that to create the base class, we need to use the declarative base function. So let's copy this over and let's instantiate the base. And then we want to design our table. So I'm going to copy this because we'll need these imports. And let's start designing our table. So what I want to do is create a class called, we want to call it price because we're going to store the price to the database. And if I refer back to the documentation, we want to subclass base. So we have price, we're going to subclass base. And then it says here that at the minimum, we need to define the table name attribute and at least one column, which is part of a primary key. So we can define our table name, and we need to also define at least one column. So with a primary key, so that's going to be the ID, and then we can start defining the fields that we need. So we said that we would need to store the metal, the price, and the date. So let's store the price, and the price is going to be a column, and it's going to be a data type that we haven't imported yet. So let's look at the available data types, because what I want to do is I want to save the price as a decimal number, not as an integer. So we need to import the decimal type. So let's look at how to get that data. So going back here, I want to find the data type, or the available data types. So let me look at perhaps the mapper configuration. Okay, let me just search for float. Okay, so SQLAlchemy.types float. I think this is what we need. So let me scroll to the top. Okay, here we go. Column and data types. So there's generic types, and this is what we want, I think. The float. So I'm going to open that up, and it says that the class SQLAlchemy.types float. Okay, so this type returns Python float objects by default, unless the float.asDecimal flag is set to true. All right, so I think this is what we need. So I'm going to import float. So from SQLAlchemy.types import float, and we also said that we need to store the date. So let's look for a date type. So under generic types, I'm looking for date, and then there's datetime. So I think datetime is what we want because that's a bit more precise. So let's open that up. And so date and time types return objects from Python datetime module. Okay, so this looks like what we need. So datetime. So I'm going to do import float and datetime. So our price is going to be of type float. And I just want to make sure that, I just want to check to see what kind of arguments we need to provide to float. So float, and precision equals none, asDecimal equals false. So this type returns Python float objects by default unless the float.asDecimal flag is set to true, in which case they are coerced to decimal objects. Okay, so we want to set it to decimal, where the data type is more suited to prices. So let's do that. It's a float asDecimal equals true, because by default it's set to false, and I think that's all we need. Then we want to store the date. So we'll call this created at, and then this is also going to be a column, And for the type, we're going to pass in date time. And I believe that's all. Okay, now what else do we need? We also need the metal. So for the metal, I'm going to create a different class because I want to be able to track metal separately. So I'm going to create a new class, and we'll call this metal, inherit from base. And of course, we need these two these attributes. And I should have fixed this. Instead of users, it should be price. And then the table name for this is metal. Okay, and for the metal, the only other attribute that we need to define is the name. So I'm going to call it name. This is a column, and it's going to be of type string. And we also want to connect it to the price database table. So I'm going to define a relationship. So prices equals, and we need to define a relationship. So I'm going to go back to the documentation and look for one-to-many. So basic relationship patterns, and I'm going to import this. And essentially I want to create this type of relationship one-to-many, because the parent, in our case, the parent is equivalent to the metal, and the child is equivalent to the price. So the metal can have many different price points because we're tracking the price over some period of time, like multiple days or months or years. And then the price has a relationship back to the metal because each price is a price for a particular metal. So this is the one-to-many relationship that we're going to define. So we imported the relationship, and we just need to define it now. So we want a relationship to the price, and I'm going to do a back ref to metal. And so this just allows the metal instances to be able to query for prices, and then we can get all the prices that are associated with this metal. And then at the same time, I also want to define the metal ID here, and this is going to be a column of type integer, and this is going to be a foreign key. So where's this imported from SQLAlchemy? So I'm going to import foreign key, and this refers to metal.id. Okay, so I'm going to save this. So what we've done here is that for every price object, we are now going to be able to look at the metal and be able to tell exactly what metal this price is related to. And the same for metal. For every metal object, we'll be able to tell all the prices that have for that specific metal. So now that we've done this, let's go back to the original tutorial, and I want to now commit this. So the next thing to do is we then want to create the tables. All right, so now I want to, well, let's run this first. So I'm going to open up my command prompt and clear the screen. I'm going to type in Python database.py, and it looks good. There aren't any errors. So because we have echo equals true set here, that's the reason for all this, all these log lines. But if we were to set echo equals false, then most of this would disappear. But it's nice to have this level of verbosity just so that we understand exactly what's happening behind the scenes. So what's happening here is these SQL statements are being executed, and So we're creating the table for metal, and we're also creating a price table, and then this is being committed, so the table is actually created. But because we're using an in-memory SQLite database, this is not persisted. So we don't actually have this saved anywhere on our computer. We're just using it in memory. So it's nice to quickly test things, because if I were to run this again, the same exact process would happen, which is that this engine instance would be created and bind to this in-memory SQLite instance, and then we would be defining these tables, and then we'd create the table, and that's basically all that would happen. But I now want to actually create some rows, so I'm going to scroll down here, and here we go. So create an instance of the mapped class. So to create an instance, we basically instantiate the table, provide in values for the attributes, and then once we've done that, we can then add it to the session, and then once we've done that, we can then commit it. So until we commit it, it doesn't really get saved. So let's do that. Let's first create an instance of our table. Or let's start with metal. So I want to create a new metal called gold. So this is going to be metal, and we know that the metal table has a column for a name. So we're going to give this a name. We'll call it gold. And then we're going to create a session. We haven't done that yet, so let me scroll back up here. So session equals session. We need to create this. But I believe, yeah, we need the session maker. So I'm going to import the session maker. Excuse me. And then with that, we can create a session instance and bind to the engine. And the engine is what we declared up here to the in-memory SQLite. And then we can create the session. No, we've done that. And then we need to create a session instance. Okay, so now we're now ready to add the new object that we created to session.add, and then the gold object, and then we want to session.commit, save it. Let's run this. So as you can see, it went through the whole process again of creating the tables, and then it created a new row. So it inserted into the metal table the new metal object with the name of gold, and it committed that to the database. So how do we verify that this actually exists in the database? Let's go back and look at the documentation for querying. So I think if we scroll down a bit, it tells us how to query or get the data from the database. Here we go. So a query object is created using the query method on session. So we do session.query, provide in the name of the table, and then provide some filters. So let's try that. So once we've created the gold, I want to then do session.query and then provide the name of the table, which is metal. And we'll just do all for now. So I want to say print metals in database, and we'll just print that out. So let me open up my command prompt and run this again. So this time it did the whole thing again. It created the tables, inserted this metal into the metal table, and then we have our output here. So what we got back was a metal object, a list of metals containing only one item, because we only created one metal. So looks like it's working, but I want to make sure that there isn't anything persisted, because there shouldn't be. So before we actually create the the new row, I want to run the same query just to make sure that that it's empty. And we'll call this after. Okay, let's save that and run it. So as you can see, previous to creating the row, there's nothing returned from the query. And then once we create the row and we do a query, we can see that it gives us the metal back. All right, so we now know that we're able to create a metal and we're able to add it to the database. So the next thing I want to do is I want to create some prices. So let's create some prices. I'm going to say my price is price, and then we know we need to pass in the price. So we'll just give in some number like 23.45, and we need to also provide a created at. So for that, I'm just going to pass in the current date or current date time. And for that, I'm going to import date time. And then, well, actually, I should put this at the top because this is from the standard library. And then I'm going to create an object. Now is datetime.now. And we'll pass that into created at. And we also need to pass in a metal. So we'll say the metal ID is, so let's get the metal ID for gold. So what we can do is we can query for gold. So I'm going to say gold ID is equal to session.query for metal. And then I can say filter where the metal.name is equal to gold. So let's try that first. What is gold ID? And I'm just going to comment this out for now because I want to see what this variable is. So let's run that. And it tells me that gold ID is a SQL statement. So what's going on here? So session.query metal.filter metal.name equals gold. So let me look back. What did I do wrong here? So let me see what the type of gold ID is. And let's run this again. So it's a query type. All right, so so what we have here is a query, and what I want to do is get the first object from that. So I'm going to delete this, run it again. Okay, so now we have a metal object. And so if I want to get the ID, I can just do gold ID. I can just say gold.id. And if I run this again, we now have the ID of that metal. So this can now be passed in to the price. And I'm going to say the metal ID is gold.id. And just as before, I'm going to add this to the session. So I'm going to do session.add price. Then I'm going to commit it, save, and let's run that quickly. Okay, so we have now created the gold metal, and then we created a price object. So as before, I want to query the database and make sure that our price is actually stored to the database. So I'm going to do price is session dot query the price table dot all, and let's print that price object. So this is going to be another, it's going to be a query set, I think. So let's run that. Yeah, so we have a list of price objects. And then if I want to just get the first one, we get the actual object. And if I want to print out the price, we can then do the price is that, and then we can also say date and print out the date, and as well as print out, what else do we have in this table? So we have the price, date, and the metal. So we can say metal is price object dot metal dot name. Let's try that. Okay, so what we got back was the price, the date, and then the metal. So let me remove echo, or set it to false, and then run it again, clear the screen. Okay, here we go. So without all the verbose logging, we get a much cleaner output back. So prior to committing anything to the database, when we do a query, we get nothing back as expected. Once we add some items and we do a query, we get that item back. We created the gold object and we printed out the ID of that object. And then finally, we created a price object and we printed out the attributes for it. So we know what the price is. This is a decimal number. We could add some precision here, so we could limit this to like 2 or 3 decimal places, but I'm just going to leave this as is for now. We got the date back. This is a datetime object. Since we didn't specify time zone, this is going to be UTC. And then the name of the metal. So now that we have all this working, what I want to do is I want to refactor this so that we have a database library where we can just import what do we need? We just need the session. So we need to be able to import the session and not have to do all this every single time, not have to initialize it every single time. So even before that, let's change the in-memory to a file. So I'm going to call this our database.db, or I'm just going to call this prices.db, and let's run this now. And if we do this and I list my directory contents now, you can see that we have a prices.db. And if we run it again, so you'll notice that if we look at the output there, so metals in DB before, it's empty. And then once we add the entry in, the database has 1 item. So let's run this again. So if I do python database.py again, now we can see that at the very beginning, where previously it was empty, we now have 1 object in there. And then in the DB afterwards, we now have 2 objects in there, 2 metal objects in there. So this shows us that our data is now persisting to the prices.db file. If I run this again, you'll notice that we now have 3 items, 2 items initially, and then we add 1 more. We have a total of 3 items in there. So we know that the prices are now being persisted to the database. So what I want to do now is I want to clean this up so we have a clean interface for creating metals and creating prices. So to start off, I'm going to create a Python class, and we're going to call it our DB, we'll just call it database. And the first thing I'm going to do is I'm going to move all of this into the constructor. So we know that we need to define the engine. So the engine's here, base is defined there. So I think we can move this down here. So I'm going to move this here. So we create the engine. And we instantiate base. And then we need a session. So we know that we need to make this available to our method. So I'm going to say self.session is equal to session. And then to create a metal, I'm going to do define create metal. And so we need to pass in the metal name. And given that we have a metal name, we're going to add it to the database. But before we add it to the database, I want to make sure that the metal doesn't already exist, because I don't want multiple metals with the same name in there. So before we actually create the metal, we're going to do a query. So I'm going to do self.session.query, and we're going to query for the metal table, and filter for metal.name is equal to metal. And we want to check if this exists in there in the database. So I want to look at the documentation to find the exact method for that. So looking at the documentation, I want to look for, okay, so if we want to check for equality, we can do equals equals, not equals, like. Okay, I'm just scrolling here. I'm just looking for something like exists or has or something like that. So all returns a list. Okay, here we go. So the query.one method is great for systems that expect to handle no items found versus multiple items found differently. Okay, so I think we can probably just use this. .one. Okay, but this will throw an exception. Applies a limit of 1 and returns the first result as a scalar. Okay, so let me look a bit more. Okay, I'm just going to Google for this. So okay, how do we check for data to see if it exists? It says that, all right, we can use exists. Yeah, so I think we're just going to go back and we're just going to, we'll just call first. Right? So we'll call first, and then we'll see what the results of that is. Okay, I'm going to comment all these out for now, because I want to, oops, how do we bulk comment? Edit, comment on comment, block comment. Okay, so all I want to do is I want to check to see what this is, and I'm hoping that it's either going to be an object or it's going to be none type. So let me just do a quick test. And I'm going to say database. Okay, so save that. Let me run it now. Excuse me, base is not defined. Line 10, so line number 10, base is not defined. We need to move this back up. Save, run. What's going on? Engine is not defined. Okay, we can move this back here. Okay, let's try again. All right, so we got an object back, but I'm going to delete the database. So I'm going to delete prices.db, and if I run it now, I should get none back or nothing back. Okay, so as expected, it gave me none back, which means that I can use the first method to tell if an object exists or not. Okay, so now that my test is done, I'm going to leave that for now. I'm going to undo this bulk comment. So bulk on comment. There we go. All right, so if the object exists, I'm going to return false. And then otherwise, I'm going to return the object. And in fact, we can simplify this further by just returning object, because it's either going to be a metal instance or it's going to be none. So let's add that to our doc string. Okay, so we can simplify this further. We can just do return. Nope, excuse me. We're not creating it yet, so we still need to do this. Dot first. Okay, so if the object exists, then we're going to return it. Otherwise, we're going to create it. So that's what we want to do. So I'm going to delete this, and I'm going to say gold object is going to be metal, name is metal, and we're going to add it to the session, and we're going to commit the session. We'll return true and return false. So basically, what we're doing here is we're creating the metal if it doesn't exist. If metal exists, return. So if we create the metal, if the metal exists, return false. Otherwise, return true. Okay, so I think we need to break this up. This is rather long. This is 90 column. Okay, so let me reduce the font a little bit. Okay, so we now have a method called createMetal, and what it does is it takes a metal argument of type string, and if the metal exists, then we just return false because we didn't create the metal. Otherwise, we create the metal and then we return true. Yep. So now we can move this into here. And so now what I want to do is I want to test out our new database class. So the first thing I'm going to do is move this back up here. Okay, so we want to print out the metals in the database. So let's create another method for that. So I want another method which is going to get the metals. And so what I want to do is I want to self.session.query for metal.all. So I want to return all metal objects. So let's do this. So metals in DB before, and we'll call d.getMetals. Move this above. And then once we create the metal, we're going to do an after. Okay, let's save that. And I'm going to comment this out. Let's do a block comment. Save, and let's run. Session is not defined, line 54. So line 54, yep, we need to fix this self.session.commit. Okay, let's try again. All right, so it's working as intended because what we expected before was an empty database and then after at least one metal object. Or excuse me, exactly one metal object. And now if we run this again, the database already had one metal object because that persisted from the previous run, and then we now have the same metal object. We don't have a duplicate metal object in there. If I run it again, you can see that we still only have one metal object in there. Now let's see if we add in another metal, and we'll call this silver. And then print this out. We can see that before we only had one metal object. We tried to add gold, and we still only got one metal object in the database because it didn't duplicate gold. And then when we added silver, we now have two metal objects. And then if we run this again, as expected, before there's only two metal objects, that's gold and silver. After, gold and silver. And then when we try to add silver again, gold and silver. So we have essentially tested and ensured that we are able to create metals using the create metal method, that we're able to ensure that duplicates don't happen because of this check over here. And then we've created a method called getMetals, which returns all the metals back to us that are currently in the database. Now, the second thing we need to do is we need to create a method for adding in prices. So let's do that now. So I'm going to create another method called create price. And this time we need not only the metal, but we need a couple of other things. We need the price, we need a created date, and we need the metal. So we need the price, created at, and we need the metal. So we're going to create this again, similar to what we did over here. So we're going to copy this, and what we want to do is we want to query the price table, and we then want to filter for price.price, and let's change some additional filters. Filter, we're going to say price.createdAt is equal to the created at value, and then we want to filter for metal equals metal dot first. So if this exists, then I want to return false. Otherwise, I want to create the object. So I'm going to say the object is price, and then we'll pass in the arguments, which is price equals price, created at equals created at, and then the metal equals. Now we need to actually grab the actual metal instance, because we don't want the user to have to grab that for us. So what we're going to do is we're going to say metal object is equal to metal dot objects dot excuse me. So what I want to do is I want to either I want to get the metal object, but if it doesn't exist, I want to create it. So we already have a method called createMetal, but right now, if the metal object exists, we're just returning false. So instead, what I want to do is I want to return the object, because then we can use it in our createPrice method. So I'm going to say if object exists, return it, and otherwise create it, and then we can return the object. So session.commit, and we can return the object. Okay, so now let's look at the create price. Metal equals metal object. So this is either going to be an existing object, or it's going to be something that was just created. So self.create metal, pass that in. And okay, so we should have a metal object now. Now, before I actually create the price, I want to verify that this is indeed working. So metal object. So I'm going to print that out. I'm not going to create this for now. And I'm going to comment this out. And I'm going to call the createPrice method. I'm going to pass in a price. Let's say 22.45, and then created at, we'll just pass in datetime.now, and for the metal, we'll pass in, let's say, gold. Okay, so let's clear the screen and run it again. So it tells me that the metal object is indeed a metal object from the database, but let me delete the prices database and run this again. So we know that if the object exists, what we've done is we've essentially just tested that the createMetal method will return the object if it exists. But what I want to test now is if it doesn't exist, I want to make sure that it creates the object and returns that. So let's run it again, and it did just that. So it returned the metal object right after it created it. So we know that this is working. Now let's go back to the createPrice method, and now that we know that the metal object exists, we're going to use it to create the price. So I'm going to uncomment this, and we'll then return, excuse me, we now need to commit it to the database. So just like what we did over here, so object equals metal, same thing, object equals price. We then want to add it to the session, and then commit it. So make sure that SQL statements are flushed, and then we can return it. All right, so now let's create the price, and then we can now query for the prices in the database. So to do that, I'm going to create another method here, and I'm going to say define get prices, and I want to return the query for price and all rows. So we should get all rows back for prices. And let's print it out now. So d.getPrices, and let's print this before we add it, so that we know what's in the database. So I'm going to do all prices before, and then all prices after. All right, so let's run this now. So we can see that in the database, all prices before, and that's nothing because there wasn't anything in the database. And then right after, we can see that we got the price object back. If I run this again, it's now going to create two objects, because even though the price and the metal is similar, the date time has changed because it's a couple of seconds or minutes later than the first object. So these are essentially two unique objects. So now we have created a database class. This is going to be our helper, and we can then when we instantiate database, it'll initialize it for us, create the database if it doesn't exist, and then it provides a couple of methods for us to create a metal and to create a price. And then it also provides methods to get the metals and get the prices. So instead of having to manually do all this, we can simply use a really nice and simple API to create and get objects from the database. So for example, to create a price, all I had to do was to call the createPrice method and provide a price, a date, and a metal, and it would create the object and provide the object back to me. And same thing for metals. To create the metal, all we had to do was to call the createMetal method with the name of the metal supplied as a string. And then we also built in logic to ensure that duplicates don't get added. So let's clean up this over here. We can delete that because we don't need it anymore. Save. And let's test this by updating the tracker.py file. So we're going to import database. Once I have the prices, I want to save it to the database. So let me go back and let me delete our prices database, clear the screen, and now I want to, so this is from our first video where we created the tracker class and then we added in this test. That is, we added in these metals, so XAU, XAG, currency was USD, and for each of these metals, so AU is gold, AG is silver. These are just the element symbols. So for each of these metals, we got the price by calling the getPrice method. And then once we got the price back, at that time, for the first video, all we did was print out the price. So in fact, let's run that real quick. So Python tracker. Okay, so this is because from database, I want to import database. Okay, so let me try again. All right, so this is exactly what we saw last time. The prices might have changed because I'm recording this more than a week after our first video. So the price for gold is $18.36 and silver is $23.97. Okay, so we know that the tracker is still working as expected. So now what I want to do is not just print the price out, I want to save the price to the database. So to do that, I'm going to first instantiate the database. I'm going to say my db equals database. So this initializes the database for us. And then I want to, now we've hard-coded the prices or the name of the database here. So what I'm going to do is I'm going to pass this into the constructor db name, and then we'll just interpolate that here. db name. There we go. So now going back to tracker, I can then say my database name should be prices.db. So that makes the code a lot more usable. So we pass in the db name to the constructor, and then we want to create the metal. So what I want to do is for metal and metals, I want to create the metal. So db.createMetal, and pass in the name of the metal. And then I want to also save the price. So I'm going to say price object is db.createPrice. So create price, and I'm going to pass in the price is going to be price, created at is going to be datetime.now, and the, what else do we need? The metal. Yeah, so the metal is going to be metal object. Okay, and let's save that, and let me just make sure. Okay, so we're committing both. All right, so let's run this. So datetime is not defined. We need to define that here. So I'm going to say from datetime import datetime, save, and clear, and then try again. Okay, so we have a problem here. So there's an argument error exception raised that says that the object database.metal is not legal as a SQL literal value. So what do we do here? We provided the metal object, but what we're supposed to provide is metal price metal ID. So we needed to provide an integer. Okay, so let's fix that. So instead of the metal object, we need to provide in the integer that is the metal object's ID. And then let's clear the screen and try again. Okay, so this time we didn't get any errors. So presumably that means that the data got saved to the database. So let's verify that. What we can do is we can, just like we did before, we're going to print out the current rows in the prices table. So I'm going to say db dot, and the method was get prices. So I'm going to say db.getPrices, and I'm going to print that out. And then we'll do it again right at the end. So print the same thing, and we'll call this after. Okay, so save and run again. All right, so now we have the prices before and prices after. So now that we have some data in there, I want to print out all the prices because we should now have a bunch of different prices where the actual price differs a little bit, so we can see the change. So what I want to do is, instead of getting the metal, I just want to print it out. So I'm going to comment all this out, and I'm going to say for price in db.getPrices, I'm going to print out price.price. Okay, let's run that. All right, so we got the prices, and these are slightly different. So the gold price was 1836.57, and then subsequently it was 1836.58. so bumped up by 1 cent. Similarly, for silver prices, it went up from 23,975 to 23,976. Okay, great. So I'm going to delete this, and I will uncomment this part. So block uncomment and delete this line. Okay, so what we've now done, just to recap, is we created a database.py file where we defined two tables, so the metal table, the price table, and we then created a helper class called database, which has a constructor that initializes the database. We provided helper methods for creating metal objects and also price objects. And then we also provided helper methods to get all metals and all prices from the database. And then we finished off by testing that we were able to actually create the metal objects, price objects, save them to the database, and also get them back out to track the prices over time. And in our case, it was just over 1 or 2 minutes, but we could clearly see that the prices are now being saved, and we're now able to track them over time. So this is the second video coming to a close. Going back to our initial plan, we had said that in this video that we would create the Python library to actually interact with the database. So we've done just that. And now in the third video, I'm going to use the Python library called Plotly to visualize the data and graph that as a line chart. And then after that, the final and fourth video, it's going to be about using Python Celery to schedule the checking of the prices so that we won't have to manually run the Python tracker.py file manually. We'll have a Celery task, a Celery schedule that's going to run that for us automatically, and then we can leave it running overnight or over the weekend to then see how the prices are changing over some period of time. That's all for this video. Thank you so much, and see you in the next one.